All right, let's get this one done. So the equation of a model rocket is given as height as a function of time is negative 16t squared plus 160t plus 8. Determine the interval of time at which the rocket's height is above 120 feet. Now on paper, this would look like this. Where is the rocket, which is the equation, sorry, I've got something going on here. Give me just a second. All right. Plus 160t plus 8 greater than 120. Now we're just going to y1 and y2 this thing, okay? What's going to happen is we're going to have this 120, and we're going to go up over 120, and then we're going to go down. And we are interested in these times that create this path right here above 120. So we'll do that in the TI-84. Hopefully you guys are starting to figure out how to use your TI-84. We've spent a lot of time looking at graphs lately. Put 120 in y1, put the equation, negative 16, we'll have to use x to the second, plus 160x, plus 8, zoom 6er, we're going to have to look up in the sky. So as soon as mine's done working here, I'll play with the window. We're going to have to look above 120. So let's do like 150. Y max to 150. Hit the graph, and we should see everything we need to see on this one. We're not going to see the peak, but we're going to see the intersections, I think. There it is going up, and there it is going down. It's cool, I can get those times. Second trace 5. There's one of my times. Enter, enter, enter. Time 1 is 0.7574. Let's see what time 2 is. Second trace 5. And then enter, enter, enter. Time 2 is 9.2426. 9.2426. So depending on how I like to write, I might say 0.7574, comma, 9.2426. I might say something like that. I might say, if I like set builder notation, all values of x such that 0.7574, not x, sorry, t, because it's time, is between those two things. Those are both acceptable answers. All right, moving forward to number 9. Let's see, I am given some things, and I'm asked what are the known factors, and you need to understand that factors are created from zeros. Factors are made from zeros. So if it's not a zero, we're going to throw it away. Not a zero, not a zero. Now think about what these things say. That's F notation. This says x is negative 2. This says x is negative 1. This says x is 6. That's what these things are saying, okay? To make the factor, you just shift the number to the other side of 0. X plus 2 is a factor. X plus 1 is a factor. X minus 6 is a factor. Signs change when you enter the factors. There you go. That's 9. Easy peasy. 10. Given 3 terms of the sequence, write a rule. Sequence is negative 2, 10, and 22. You haven't done this in a while, but you're supposed to write a rule for the sequence. And I'm nice enough that I have given you the formula. This will be your first term ace of 1. Your difference is going to be 10 take away a negative 2, which is 12. That's the difference between those two parts. And we're just going to feed this formula. The nth term is the first term, -2, plus n minus 1 times the difference of 12. You may not remember doing this, but your goal was to look like mx plus b. That's your goal. So we're going to kick in the distributive property. We'll have 12n minus 12. We still have a -2 out front. We'll combine like terms. Variable first, 12n minus 14. Now, does this work? Let's do a check. Ace of 1 would happen when I plugged in a 1. It'd be 12 times a 1 minus a 14, which is -2. Ace of 2 would happen when I plug in a 2. 12 times 2 is 24. 24 minus 14 is 10. See how the pattern is holding? That's the correct answer. Don't know what happened there, but that's my answer. Ooh, these. Use the graph below to answer parts 1 through 5, 2 points apiece. The real zeros and their multiplicity. So the zeros are the same as your x-intercepts. There's one right here where x is -1. You got this little note over here. You should look at it. This is a touch. Its multiplicity is 2. You have another 0 right here. It's at x equals 0. It's also a touch. Its multiplicity is 2. You have a 0 right here. X is 3. However, it is crossing, and it says it's at least 1. The multiplicity is 1. The degree and sign of the polynomial based on n behavior. Oh, not what I wanted. So I know from teaching this class year over year and grading your stuff that you guys have not learned your n behavior. X to the even, high, high. Negative x to the even, low, low. X to the odd is going to be low to high, and negative x to the odd is going to be high to low. So this guy is starting high and ending low. It must be a negative x to the odd because that matches that graph right there. By the way, there's things that can reinforce this. 2 plus 2 plus 1, 5, which is odd. Okay? Least degree of the polynomial based on turning point theorem. And the little note says it's the number of TPs, turning points, plus 1. And this graph is going to be hard for some kids, but that's obviously a turning point. There's one here, there's one there, there's one there. There's actually 4 turning points. And the theorem says add 1. So the degree is 4 plus 1, which is 5. Which, by the way, lines up with that number. It's also odd. There's lots of things that are reinforcing as you go through here. The known factors come from this. You have x minus 1. Sorry, x equals -1. Shift the 1 left. X plus 1 is a factor. You have x equals 0. Shift the 0 left. X minus 0, which is just x. And then you have x equals 3. Shift the 3 left. X minus 3. And now it's time to write the polynomial. It says don't forget to find a. So let's go back to our multiplicity. This factor happened twice. It's x plus 1 squared. This factor happened twice. It's x squared. And this factor happened once, and it was x minus 3. First letter of the alphabet is an A, and this would be equal to y. You have a point you can plug in. It gives you x and y. It says 18 is A. X was 2. And then we do math. And you know, you should be trying to do math to see if you can actually match me instead of just blindly copying me, because it's not working. So 2 squared is 4. 2 plus 1 is 3. 3 squared is 9. 4 times 9 is 36. 2 minus 1 is -3 times 36 is -36. There's a -36 attached to that A. We divide out the -36. and we get that A is -1/2, and that number is going to go right there, and I will have my equation. -1/2 of x squared times x plus 1 squared times x minus 3. That's how you write a polynomial. Then we got the piecewise graph. State the domain of the piecewise function graphed. So the lowest x value is -4, so I can't be b. See how the lowest x value is -4. I run to here, and I think I have a problem, but x is allowed to be 0, so I'm not actually worried about anything. And I run all the way to 5, and notice 5 is an open hole, that's a parentheses, choice A. State the range of the piecewise function, that's going to be your values of y. The low y value is -1, the high y value is 4, so I can't be choice C, right? I could be A or B, it's about decisions. And A is saying that y cannot be 2. It says y is not 2, and that's not true. Y is allowed to be 2. It's right here, you can see that y is 2 at that point. That leaves B by elimination. State the intervals where the graph is increasing, that is uphill. I am uphill here. I start going uphill when x is 0, and I stop going uphill when x is 3. So I'm talking about 0 to 3. Decreasing is downhill. It's going to be this piece right here. It starts when x is -4, and it stops when x is 0. So -4 to 0. Constant is your flat line. Flat line starts when x is 3, and it stops when x is 5, 3 to 5. X-intercepts, I don't understand that, why this is an issue. It's 1, 0. Y-intercepts, this is the only one that's real. This is y equals -1. This is a hole. There is nothing in a hole. So 0, -1 is going to be my y-intercept. 23 is the average rate of change problem. And the easiest way to do average rate of change is to pay attention. This says x is -4. So I'm going to go to where x is -4 and I'm going to put a point. This says x is 2. I'm going to go to where x is 2 and put a point. And then I'm going to think about a line. And I'm going to think about my 7th grade math lessons. I fell 3 and I ran 6. So I'm thinking -3 over 6, which is -1/2. And 24 says find f of 0. If it does not exist, state why. F of 0 does exist. You have a choice. You can be this guy or this guy. There's nothing here, but there's something here. And f of 0 is asking for the value of y when x is 0, and it is -1. I know a lot of y'all get really messed up by function notation. I'm sorry. And here we have the bonus. I may not have enough room to do that in full thing, but we're going to do this f of x plus h piece. So we're going to do 3. We see an x. It becomes x plus h. We're going to write it twice because it has been squared. Then -2 times an x plus an h, and plus a 2. And I have a question here. Like Parker Scott, why won't you ever do these? Now, you're not the only one. You're just the one that came across my mind. Why won't y'all try it? I could probably list off 50 kids. Why won't y'all try stuff like this? This is not that hard. This is going to give me x squared plus an xh plus another xh, so plus 2xh, and then plus h squared. Minus, use the distributive property, 2x minus 2h, and then plus 2, and then clean up, 3x squared plus 2x, sorry, not plus 2, plus 6xh plus 3h squared minus 2x minus 2h plus 2. I guess maybe that seems like a lot of work to y'all. It's really not. You're just lazy. So let's start and go back to the rest of this. I have 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 2. And I'm supposed to take away the original function. So I'm supposed to take away 3x squared minus 2x plus 2. And this is all over that h. Now, whatever's in parentheses will cancel. There'll be something on the outside that it cancels with, so it cleans up very quickly. I am left with 6xh plus 3h squared minus 2h, all sitting over an h. 1, 2, 3, 4 pieces of this fraction, they all contain an h, so I can divide it out of each piece. I'll have a 6x, because that h is gone, a minus a 2, because that h is gone, and only one of the h's disappears here, so plus 3h. That is the difference quotient, aka the derivative of that function. And it's not a hard bonus question, you're just lazy. Anywho, there she is.